This is integer comparator. It says implement a type level comparator. We've provided an enum for indicating the comparison result. So, it says here's a little caveat. A and B can be positive integers or negative integers or 0. Even one is positive while another one, even it's allowable that one's positive while another is negative. Okay. But like always, we'll just, it's better to read the tests, you know? Welcome, Trash, by the way.
I'm happy to be here.
I don't really introduce people on the challenges. I kind of regret that, but I feel like if it'll be in the comments. I have been pinging. If anyone wants to know all about Trash, down in the comment, there will be a pinned comment bio. Okay, so comparator. So have you seen anything sort of like this? It's just sort of giving us a result whether or not two values are greater than each other, less than each other, or equal to each other. We'll talk about the big int size things later. But yeah, what do you think about this? Have you seen any kind of thing like this in TypeScript before?
Yeah, so like my immediate thought is obviously like when you have to compare things, you have to do like accumulators and basically compare like length of arrays usually. Mm-hmm. I know when I end up doing that, I end up hitting the limitations of TypeScript because I either do it like imperformantly or something, so I end up having to just like bang my head against the wall. But usually when I hear the word comparator, that's typically like my first kind of intuition there.
Okay. Yes. Perfect. So there's lots of tricks you can do to get around it. So here's one solution. This one is by, who is it? teamchong. You may not know teamchong, but he's like, I feel like he's a friend of mine. I've never met him, but he did a lot of the challenges. And also this person, Alexsey, did a very, very similar challenge. So we could do it any way you like, but maybe it would be fun if you want to like talk us through it or like ask questions along the way. I can answer them, or I could kind of give you a tour, whatever you think is best.
Let's do a tour because right now it's a lot. So I'm trying to follow it right now, but it kind of follows what my mental model at a glance. It kind of looks like what I would expect. But yeah.
Awesome. Okay, so we start with comparator. Comparator is the kind of entry point on line 130 here. And for that, we're going to be taking in two numbers. So they've been nice to us. Some challenges we'll see in a second allow big ints and strings as representations of numbers, but this one is nice. It just is numbers. And so the first stop here is to see whether or not they are both negative. So we can do that in one go with a little trick here. We can coerce them to a string together and then look at the concatenation of that with two minus signs in there and see if the pattern matching trips it.
That is clever. I would have never thought of that.
Oh, you're gonna love this. There's a thing at the end that it has happened once in the challenges before for math things, but it's really, really clever for, well, I'll show you. But okay, so then we have this thing, compare positive numbers. So we know that they're both negative in this case, right? Okay, so if we go down to compare positive numbers, we see, does A extend B? This is like, are they the same number? Okay, simple enough. Then we return equal. Like, this is that would be a pretty happy path. We would kind of get out right at that. But usually that's not what's going to happen. So we're going to compare by length. And it's exactly what you suggested. Compare by length is all about building up. So let's take a look at it. So compare by length, it takes in two strings. So right by now we've converted them to strings. You see, because we did that when we passed compare positive numbers, we inferred the values out. That's another trick because now we don't have to convert them to strings. Otherwise, we would have had to do like I think it would probably still pass if we did like we put A here, something like this.
Oh, gotcha.
Okay, it doesn't. But anyway. That's basically, because I did the wrong one. It's B there. Okay, anyway, doesn't matter. So that's the trick there. So they're strings by this point. That's why we can do this comparison a little easier. And then if they're equal, then we're going to see if this compare by length result, if they're not equal, we're going to start checking further. So we're going to infer, this is a kind of strange thing to do. It doesn't happen a lot, but you can infer a part of an intersection. So comparison, we didn't look at comparison yet, but here's the enum. It's pretty straightforward. It has greater, equal, and lower. So we can take that and intersect it and compare that result out. So is this making any sense so far?
Yeah, I've just never seen the infer result part before.
Yeah, it's actually, I wish there's a bug in TypeScript right now. You can't put if you do this on the same line, it doesn't understand.
But, seriously?
Yeah, I'm very proud of that one because I found it while doing these challenges, and I sent it up, and Ryan Cavan, I was like, yep, it's a bug. But anyway, so we have so we're trying to see we're trying to check the digits. So if this is false, by the way, so if we can't grab a result out, if this pattern doesn't match, then we're going to go down to comparing by digits, and this is like sort of the one of the meatier parts. So we're going to be taking a portion of each string out when we do compare by digits. So it's that same trick again on line 170. We're putting a little pipe between the numbers, and then we're inferring portions of those numbers out. So this syntax in TypeScript will infer the first character and then the rest of them. And then from here, it'll greedily infer I guess not greedily, lazily infer the first character and then the rest of them. So this is digit A will always be one single thing, and digit B will always be one single thing. And so we have to now jump back down into there. We're going many layers deep. It's like Inception.
I know, this is crazy.
So this is the thing that I think is really cool. Tell me what you think about this. Do you have any idea what it's doing? Line 184. Extends. So this
I have no idea, but I mean, it looks like at a glance it has to be anywhere from 0 to 9, obviously.
Right? It's reversed because what's happening is we're passing in, like, imagine A is 8. Let's just write it down here. Mm-hmm. Imagine A is the string 8. They're all strings by this point. And imagine, let's see, imagine B is, I don't know, pick a number. What's your favorite number?
12.
Oh, well, single digit.
Oh, yeah, duh. Let's do 2.
Okay, 2. So here we go. So we're going to say, this is really saying, does 8 extend 2? It doesn't. Okay, it could have been easy, but it's not. So then we're checking this. We have this hard-coded string here, all the the digits in reverse order. And what TypeScript will do is it will match the position of A to the left of B. See, because string could be nothing. It could be nothing on either side. So if we had, let's just say let's make the A 9 actually, just to make this really, really clear. It will still match this being an empty string. And so it's going to say, oh, I see nothing, and then a 9, which is what A is. And then we keep on going, and then we hit our 2, which is what B is. And then there can be something or nothing after that. It doesn't matter. Then, if that case passes, then
see.
A is greater than B.
I see. That is awesome.
Isn't that something?
That is, I would have never thought it. So this is like how you avoid doing like accumulators and converting.
Yes. Yeah. This is an optimization in TypeScript. If you can know, this solution very likely was built a little bit around this optimization because you have to handle very large numbers, and this one does handle very large numbers. And so you have to do tricks like this to avoid building accumulators and recursing because you hit the recursion limit like pretty much always.
Right. This is so cool. I'm going to put this in my back pocket.
Everyone will hate you if you do. But I've learned that if you just don't tell anyone that it's in your library, no one will complain.
Right.
But people, it's an ongoing joke about the challenges. It's like, why would you ever need to implement the Fibonacci sequence in TypeScript's type system? And it's like, no, that's not the point. The point is like, it's like lifting weights, it's to exercise your abilities. So yeah, so compare digits, we already know because we grab. So jumping back up then, now that we had that epiphany, digit A and digit B, because of the way the matching works inside of the template strings here, will always be one character. So that's how we can know that it works. Otherwise, this will completely fail. It'll always return lower, basically, if we pass in more than one character. So you have to be careful. It's not like checked anywhere that it's one character, although we could. So, all right, and then so if it returns the union of something, so and lower or greater than, then that's what's basically happening here. It's saying like it's we're going to return that result. So like we kind of grab that result out of here, return it from this function. That's this guy. And then in order to get that return, we infer it and then we return it again. When we return it from here, compare by digits, whatever it is, it could be greater than or less than. That's going to just propagate up the call stack. And eventually we're going to get, we have compare positive numbers and then we have comparator and then we kind of like come out and come up for error.
Mm-hmm.
So that's positive numbers. Any thoughts so far?
I just really love the compare digits optimization. That's super cool. It's just crazy, like the things people come up with to like optimizations, which is just awesome.
It's just great. Yeah. So we don't have to go as long to kind of go through negative numbers. It's not a remarkably different flow. Mm-hmm. We have another optimization here. That's these kind of 5 lines on 135 or so, where if one of them is negative, but the other is positive, we don't have to do any work because like we're done. I mean, we know greater than or equal to, if we've already checked equality, which is what's happening right here, that we already checked whether they're both numbers. We've already checked whether they're exactly equal. If, this is just saying like, if it's just checking equality at all, I mean, we could get rid of this section and I think it would probably, let's do it. It would probably, no, they don't all pass. Anyway, we could probably get rid of that and it would still function. Mm-hmm. But it's a really neat trick because then what it allows us to do is go back through that same code path that we did before. Notice we did that with negative numbers, but look at this. This is where I screwed it up. The order gets flipped because we're talking about negative numbers. It's on the other side of the number line. So the first thing passed in here is actually B up top on line 135. Right. But if you look down at 140, the first thing passed in is A.
I didn't even notice the flipping. Okay.
Right. And it's flipped because they're negative numbers. So this, and then this is, I didn't look far enough. This is the syntax that you'd have to do to convert the number to a string because we haven't inferred it anywhere yet. And so that's the kind of workaround. But other than that, it's exactly the same flow. So that's it. That's the whole, I mean, isn't this a beautiful solution?
Yeah. Quick question. Line 149, the infer result thing. Can you just, I want to make sure I'm understanding this. Can you just briefly explain infer result with the intersection of comparison lower greater?
So compare by length is going to return some value of the, I think if you hover over it, it's not the best, but it does show you that at every end, at every kind of termination of the function, it returns lower, greater, or equal.
Yeah.
Okay.
Right.
So basically what we're saying here is we're doing that check to return one of those kinds of things. And also notice that this is also compare by length is recursive. Mm-hmm. So it's going to like at each location, at each digit in the kind of like, I think there's a term for this in math, but like each register of the number, it's going to return a union of all of the digit comparisons left to right. Mm-hmm. So that's kind of what's happening. And then when we get that out, we can infer the result from there. So it doesn't give you any like help really on what the result is, but the result, it's a union, so it could be many, many things. And we're checking that against an intersection of lower and greater and seeing like comparing by length, like which one is longer.
Okay, I see now. Got it.
Yeah. Okay. And then, so I also want to show you this one. I don't think we're definitely not going to have time to like go through this in length, but in the interest of showing like super cool and interesting and different things, there's this guy MajorLift on GitHub, and he has been on the challenges, Young-sung, and has an amazing and interesting way of approaching these things. So he separates helpers. Thankfully, he loves to use helpers, and it's something I really like about his solutions. So we have a bunch of helpers. And a lot of these are prior challenges, is digit, int length, I don't know, all kinds of things. We're not going to go through this solution in great depth, but the thing that's interesting about it, if we jump down to line 281, we'll see that what's happening here is what he does is he does all of the work inside of generic constraints. And it's actually possible to write TypeScript types this way. And I think a lot of people may not know this works this way. And if we look at the rest of them, unsigned int comparator, you see that like all of the actual types end in just the result. So he has a convention that he's developed for returning this. But what's cool about that is what he does to solve the challenges is he writes them in JavaScript first. And then he translates the JavaScript to TypeScript using this style, which does work, where basically every line of TypeScript or every line of JavaScript is a new generic constraint, like a new line. And he goes down the list and implements things, but what you get out of that is you can create variables. Like you can basically store values, even if it's just like something you can rename something or something that you used before. Right. So he uses this approach to translate. So anyway, we're not going to go through it, but I thought it was a really cool thing, and I love his challenges. I was so happy to have him on the challenges, and it's a very different way of doing these things. I'm not sure it's good or bad or whatever. I'm not making a judgment on it, but I think it's interesting, definitely.
Yeah, this is crazy. I'm curious, like, if there's like performance implications. Like, is it faster maybe, or is it slower? I don't know, but this is crazy.
I've also wondered that, and it's you're not the first person actually I've shown something of his to that's asked that. It's a good question. I don't really know. Sometimes it gets confusing to me because it is possible to do like look at line 333. There's recursion in the generic parameter for the same, like, it's a little weird. Like, I think it was Chandler Prahl, who's from Elastic, he has worked in Elastic and EUI. He and I were looking at one like this, and he was asking, like, what is the execution order there? I don't even know, like, how does that terminate? Like, what happens? Mm-hmm. I'm not really sure. TypeScript figures it out, you know?
That's nuts.
But
that's next level.
It's next level for sure. Yeah, definitely next level. So, all right. Well, that's it for that one. Let's move on to the next one. But yeah, fun one, right?
Yeah, that was awesome. That was super cool. I learned some new tricks today. That's awesome.